Good morning, ladies and gentlemen of Precalculus. Welcome again to room 15, where it never ends, even when Haley's gone, which she is. So the first thing I want you to do today is look at your formula chart. And you're going to see in a little while why I ask you to do that. What I want you to do is go to your formula chart right here. And at the very top, you see the very top where it says trigonometric functions and identities. See that? Okay, ready? You have your formula chart out?
Yeah.
Okay, what else I want you to do is I want you to put a couple formulas here. I want you to put somewhere on the side, I want you to put S equals R theta. Oh, you don't have yours? Yeah, you could. You want to have another one? Here, take another one.
Yeah, I was too busy learning.
Too busy watching the calculator videos? Okay, yeah, that's really helpful. Okay, and so that's 1 theta. And by the way, these are called arc length formulas. These are arc length formulas. And then also another version is S equals R theta times pi over 180. So these are two different versions of your arc length formula. Okay, and the reason I'm bringing this up today is we're going to be doing exercises based on these formulas today. Okay? Now, I think I already mentioned arc length formula, didn't I? Couple times. Okay. So now we get to our exercises for today, which are going to be employing the arc length formula. So it says, problems 25 to 32 use the appropriate arc length formula to find the missing information. And basically what you have is actually S, we'll put S equals. Our formula is going to be S equals R times theta. And to refresh your memory, S stands for your arc length. And then R is going to be your radius. Theta, that is theta. Theta is going to be your angle. And theta is going to be in radians. Now, there's another version of it. I had you write in your formula chart. It's S equals R theta times pi over 180. What does this pi over 180 do? Yeah, so this pi over 180 is a factor that will convert this angle in degrees into radians. And so if you have an angle in degrees, use this bottom formula. If the angle is in radians, use the top formula. All right? So we're going to be doing some of that. So the first one, we have S is equal to R theta. So basically it's S equals radius times radians. Radius times radians. So S is going to be equal to 2 times 25, which equals 50. And your units are the same. inches. 50 inches, so that's going to be it. And basically, what a radian is, pi radians is equal to 180 degrees. So if you take 25 radians, what's that going to be in degrees? Well, it's going to be 25 times about 57 point. Yeah, I think it's 57.3. So it'll be that many degrees.
What?
So that's going to be about almost full rotations of a circle. That's what that is. Okay, so one point you're trying to make here is that you can have an angle that's more than 360 degrees, right? How? Okay, let's say that I want to do, I'm playing basketball. I'm going like this. I want to make a 360 dunk, right? So I jump and I spin in the air.
I think left.
That's a 360 dunk. If I do it 4 times, and you see that in ice skating, right? They do the 4 thing. Well, then they would do.
I did whenever we were ice skating. I spun in a circle.
Oh, very cool. Did you do the deal like this, where you put your arms in and went spinning faster?
I just spun in a circle. And then a little kid ran by, and I didn't want to step on him, and I like leaned backwards, and I tripped.
Yeah, that happened.
But
That happened a lot.
I
I'll
did
tell
it
you,
again, and I didn't.
the worst thing. I'll tell you one thing that happened. There was a friend of mine I had back from my mission experience, who lived in Galveston, or near Galveston. He still does.
What?
And so I went down to visit him, and him and some friends went skating on the boardwalk. We rented some skates, and there was a phone. I was talking on the phone, and while I was talking on the phone, I slipped off my skates and I fell into a garbage can.
Oh, no.
So I fell into the garbage can. The first thing I did is I just looked around. I said, "Gosh, I hope nobody saw that." And I didn't hear anybody laugh or see anybody look at me. But have you ever done that where you do something that's really embarrassing? You say, "Gosh, I hope nobody saw that."
He does that every day.
Okay, what I'm going to do is I'm going to call on people to help with some of these here. And for that, I'm going to go to our spinning wheel. So for this first one, we're going to have John. So John's going to do this one. Good job. Okay, so John is using the arc length formula. Multiply those together, gets an arc length of 70 centimeters. Does everybody see that pretty well? Okay, good. Thank you, John. Good work. Good work. Okay. The next one here is sort of, you have a different employee of the formula. And I'll tell you one thing that happened here is you want to find radius. So one thing, I had a friend who was studying to be an electrician years ago, and he had to take an electrician's test. And so the main formula for electrician is what? It's E equals IR. Okay, your voltage equals your current times your resistance. Right, that's it. So he says, so he was kind of struggling because he asked us in different ways. What I told him to do is there's something called a magic circle, where you go like this. And what you do is you put E, I, and R. And so whatever you're trying to solve for, if you want to solve for current, then you just cover the current, you'll get E divided by R. If you want to solve for your resistance, then you're going to take E divided by I. If you want to solve for your voltage, you take I times R. Well, this one, the reason I bring this up at this point is this is a similar type of situation, isn't it? You have S equals R theta. So here, if we're trying to solve for R is equal to what? S over theta. And then you can just plug in, and then you solve for R. So I want to call on somebody to do that. And the person we're going to call on is Bryce.
Oh, she has.
Then I'm going to have to repopulate our
Hillary did.
populate our.
Why?
Give us a try.
Yes, she did.
Why does she look really good?
If you're just a bad new thing.
Yeah, she really goes bad. It's amazing.
Okay.
The same thing.
The piece?
Is that right?
Remember, what is E? These two numbers.
Yeah, you don't talk about
Extra girl, she's taking you on two pieces. Extra girl, she's taking you
Yeah, I don't want this right.
All right, yeah.
Is that where you saw that?
We can handle it. If it's not, we're good if it's not.
Oh, okay. That's lovely. Oh, I thought you said if y'all like both of them are with y'all street open. You got with food. Well, I thought. Oh. Every time he sees me, I'm always every time he sees me, he goes, okay.
He said, watch this, you can say I look at Yeah. Did you say that thing?
Okay, thanks.
I would let sometimes, but I told that.
Or these things?
Okay, one thing you can do on this is, so this is an answer, this is called a decimal approximation, but also you have R, you can write it as R is equal to S, which is 1.5, divided by pi over 4. And dividing by a fraction is the same as multiply reciprocal.
Practice those?
Who's?
Oh, practice.
Who's little sister?
So you can also write this as 6 over 5 feet, right? Does that make sense? And the reason I do this is because Bryce definitely has 100% right answer here. But what did I tell you we're trying to do with pi sometimes? We can leave it in terms of pi. So just try to get in a little bit of a habit and practice of doing that where you can. That's all. Does that make sense? Okay, I want you to do, and what I did is I repopulated the whole wheel because Bryce was the last one. So you might get picked again, even if you've been picked already. So I'm going to pick somebody to do number 28. Okay, for this one here, we have Steve-O.
I don't know what the heck
So he got, is that pi there, Steve-O?
Yeah, that's supposed to be high. I just did
Pi,
not
right,
draw
that's
that.
pi, okay, yeah.
Yeah.
So 7.5 over pi,
Yeah.
that's centimeters. Okay, so that's pi there, all right?
Yeah. That did not,
Pi.
that did not come out as fast as I wanted
7.5 pi centimeters.
to. Yeah.
Questions on that?
No.
No questions on that? Thank you, Steve-O, appreciate that.
Oh, it's the same thing.
Okay, next we have problem 29.
Riley, is she senior?
Mr. G,
Yeah.
this be theta equals S over R?
Yeah, exactly. So Bailey says this is gonna be theta equals S over R, is that right?
Yeah, okay.
That's gonna be right.
So it's not the, so it's not the secant equation?
So for this one, we have con man.
Yeah, that's
Yeah.
what it's using.
S R O. Look at the little circle there. Right here.
Who is Freddie?
I got that answer right earlier, but now it's not.
So next one's gonna be this one. We want to come off something?
Should we ready?
157, 142,
Right.
85.
Who is Freddie?
It's just that.
No, he's Saturday. Ready, William?
Block.
So 3 radians, right? Okay, good job. So the units of meters will cancel each other and you're left with just radians. Okay?
Why did you turn into decimal? Who's left of us first? 747 radians.
Yeah, I don't like the fractions, but that's just not easy. That's-
Well, let me try number 31. Oh, no, never mind. It's gonna-
Next.
Yeah.
Leave us out one.
Yeah, that's a pretty good discussion in the third period over this problem here, a little bit. It's good. Talk about that.
Oh, it is. I understand. I feel like, what? It
No,
sounds like he's at 25.
Okay, we have Pate for this one.
I just stopped talking to him. It was like- I was like, 42. No, I stopped talking.
You just tell him to show that face. That's
Then
exactly
he
what
walked
I'm
by later and he commented on my shirt. And I'm like, "This color is-" I was like,
Which is
yeah,
pretty.
1, 2, 3. Oh, yeah.
I
Hey, Benji.
Appreciate it.
Wow.
Weird guys.
I'm gonna,
Yeah, we start hang on up here. Unless we need to,
Okay, 4/7 radians, is that right?
right?
So,
I was gonna think of
so
model.
we got, so what do you got?
I'm gonna
Yeah.
take myself to the
So basically, it's, you have S, 4 inches
What?
equals
Yeah.
radius, theta, and you divide these out, you get 4/7 of a radian is what you get, so this is the correct answer, okay? Question on that one?
I never said that.
Okay, now, are you gonna have to use, are you gonna be able to use the same formula for problem 31? No, you're not, because of degrees. No, I don't want you to use the formula, I'm gonna call on somebody to do it. Could be,
What?
if you have trouble with it, get help from a neighbor,
Don't act like you did it.
because that's part of the learning pyramid. Did I ever talk about the learning pyramid in here?
Oh, yeah.
I have, right? Learning pyramid. And that's you guys helping each other, right? Learning pyramid.
Great question right there. That is a good one.
You know, I feel like I should just stop.
Could you estimate?
I like.
Okay, for this one here, we have Kim.
Just start talking over.
Okay, well, in that case, I get short nails. Is this rotating height?
That's not up his right.
Oh, okay.
That's how you set it up? Shut up. So what do you set
Hey,
it for?
hey.
Why?
I is a number.
And here's the one that- Why? What do I do to divide?
And I was like,
Both sides?
Yeah, to get it off the pond.
So most likely this one,
I see one divided by 20.
but then we would just show me a list if I had to.
Pi there, 7.5 by 25.
But you just told me to look at 5 by 18 and then look at. How would
And
I?
then, so
So what is it?
That's right.
365?
No, teacher, the old square is on the bottom. This will be close. Centimeters.
What is it?
Oh, it's centimeters.
So where would I put that? Right here?
That number is centimeters. I think the other one is.
Oh, wait, what am I, okay. There's 160. What?
Yeah. Yeah, that's why I got that.
Yeah, I can do it. What question? You're right. I'll have to go to What happened?
What happened? Yeah, what happened is you turn on the,
Oh, yeah.
you hit the board.
Yeah. I didn't know that.
Yeah. Somebody hit something, brush
There's a lot of sense. I like
Just checking it right now.
They also
Divided by 25.
yeah, they're not ready, yeah, ready.
It's not 20 feet, I think they're growing, my shoes on.
So she got radius equals 360 over pi, is that right? 360 over pi centimeters, is that right? Bailey, did you get that?
I didn't know how to do it,
Let me
so.
show you, how I would, she just did things in a different order I would do it, but she did it right. And one reason I know it's right is because we just had we just had the other class do it, so I saw that. So we have is, so Bailey, the first thing we want to do is we're going to find radius. Radius equals r divided by theta, right? You have that, Bailey? So radius equals r divided by theta. And so what we have is radius is equal to s divided by theta, excuse me. Radius is s divided by theta. So here we have 40 divided by theta, and theta we get is 20, and since that's degrees, we're going to multiply that by pi over 180. So are we good? Are we good up till now?
Yes.
Okay. So let's go, what's 80 divided by 20? 9, right? So R is equal to 40 divided by pi over 9. Right? You see that? So now if we multiply by the reciprocal, R is going to be 40 times 9 over pi. What's 40 times 9? 360.
If you're gonna say something stupid, I can literally do letters and engineering school and have you ever heard of
Okay?
engineering school?
All right. Are you okay on that? Okay. Let's go to the next one here. 32.
Let me guess what it's gonna be Jack?
It is going to be Jack. How did you know?
Oh, my goodness, I'm supposed to. Actually, Jack.
Yeah, it is Jack.
I don't even know what I'm doing. I don't even know what I'm doing right now. Did we know your phone? At least you didn't script it.
I didn't say that.
You're gonna find a look one day, but it's a voyeur.
Okay, thank you.
What?
Here, stick. Anybody get that?
I didn't see why it practically.
One thing we have to do is what?
Why it's always in the back next to things.
What unit? C?
Sorry.
And also, he does whatever they do in the back, like.
I built a grill.
So R, this is the thing, R theta.
A grill.
So, I don't know why he did that. Because multiplying by 180. Here's what I would do. So, it is right, but here's what I would do. I'm just gonna retrace this a little bit, okay? He did get it right. But here's what I do. He's using the right formula, right? S equals radius times radians, which is 18 degrees times pi over 180. Well, this stuff here cancels out to be 10. So we have this S is equal to 5 times pi over 10. And 5 over 10 cancels to be over 2. So you get pi over 2. And the units carry over feet. Okay? Questions on that one?
No, I'm just copying it. And Mom's sick.
Okay. So the last four are slightly different types of problems. So I want to go ahead and go over those. I want to go show you like number 33. May I show that to you? So basically, you said angle theta intercepts arcs S1 and S2 on two concentric circles with radii R1 and R2 respectively. Find the missing information. What I do for this one is I find it helpful to draw a little diagram. So the two concentric circles are first, I'm going to put this one here in blue. So there's one circle. And then I'm going to go ahead and take a green circle that's bigger on the outside. So these I've drawn are two concentric circles. Okay, and the S in R1 is going to be 11 centimeters, so that's 11 centimeters. And R2 is going to be a total of 44 centimeters. So I didn't draw it exactly to scale, but you can see what's happening, right? And then it says for a central angle, we have theta. We don't know, but what do we know else? We know what S1 is, right? What's S1? 9 centimeters. So I'm going to go ahead and take in red. I'm going to draw an arc here. So this right here, I'm going to call it S1. So there's your S1, and the angle that S1 creates is this one right here. So this is our angle, this is our arc, and we're trying to find what? We're trying to find two things. We're trying to find S2.
Yeah.
So here's S2 up here. We don't know what it is yet. My pen is a little bit glitchy, all right. And also we want to find what this angle is. So what is this theta right here? What is it? Question mark. I've just drawn. That's our theta. What is that angle? What is S2? Okay, which one would you try to find first?
S2 angle.
I would be, that's what I would want to do. You're given S1 is 9 centimeters, so S1 equals 9, right? Now, that's what I would do it Steve-O's method. I would just want to find S2. How would you do that?
Wouldn't you just have it by 4?
Yeah, you could do that, huh? You can just multiply by 4, because you see our proportionality, don't you? And that's gonna be equal to S2 over 9, right? And so what happens is you can take, did you say that, Bailey? Was that you? Yeah, you can just take, this is gonna be 4, right? So S2 is gonna be 4 times 9, so S2 is gonna be equal to 36 centimeters. And what I want you to do is I want to call on somebody to find me what your theta is. Since we have that, what is theta? I can call on somebody. Theta is,
Oh, it's funny, because when I think about this.
we have Sal. Sal, you're going to tell us what theta is.
Get it? Mine is like,
So Sal's going to figure out what theta is.
is it mine?
Yeah, theta. You figure what theta is.
Okay. And.
Yeah. Okay, whatever, shut up. For district? Should I go get one for being a track manager? Manager?
Uh,
Yeah,
45.
I did it.
Because I looked at them today. I have 47. 50. I have 45.
Wait, so how do we have that since you were from
And the project is like, what, 45?
over the summer, we ran it in like days, like school.
Yeah, we put it in. For what did you do? The board and stuff?
Boards and
Yours already
stuff.
there. She put it in there. Why? They all do.
This is
I don't know, I'm trying to do this thing. There.
I got the next one, I got the arch on, next one, I got the arch on.
This call.
Because we didn't.
Oh, we still have it like that?
Was
I
all
think
not
it's
here.
3.6.
So instead of using those, use
Yeah, that's a meeting, but.
So I think when you go to meetings, or you see,
And you get 3.7.
over.
Okay, guys, I don't know this.
Oh, you're trying to do that.
Oh, I thought I was doing this problem. You're doing three.
So yeah, I'm trying to find the,
Oh my goodness.
So it's S over R?
yes.
9, 11.
Jimmy's only picked up tonight.
S1 or S2?
S1.
Just do S1 and R.
Okay.
9 and 1.
Oh my God, I can't do that, you know. That I can't do. Yes. That one good, I'll do that.
Okay, that's easy. I thought I was supposed to be doing that for.
Hey, right for what? Oh, we rolled up on.
Is it radians?
Radians, is it radians or degrees? Radians, right? Radians, right? Is that it? Yeah, you could do that, right? And if we wanted to convert it into degrees, how can we do that, Steve-O? Thank you, good job.
How do we do that?
Yeah, we could multiply that by pi over 180, right?
What?
Yeah, I was thinking almost 180 times.
Just now?
Pi over 180. So, but another thing I told you was, remember I told you that 57.3 is 1 radian, degrees of 1 radian?
Oh, okay.
So you take 9 times 57.3 divided by 11, so that many degrees, times, excuse me, 9 times 57.3 divided by 11, so that many degrees is about what it is, okay? Okay, I'm going to call somebody at number 34. I think that'll put us in a good place for today.
Can I volunteer?
Maybe we'll see if you're close to it, I'll pick you if you're close to it. So Luke, you volunteered? Yeah, Luke has volunteered, so I'm going to go ahead and take Luke's off. I appreciate him doing that. And then what we're going to do tomorrow, we're going to pick up on 35 and 36. And it's going to be at the beginning of class, it'll be like a fresh attention span on it. Hey, I really want you to pay attention to that. Everybody stay seated until this class is still in session, right?
Just write the answer that.
Well, yeah, just show how the equation you solved. You can just show that. Make sure you show your equation.
No, I said it is. This, I thought we were done the last one.
So you want to do loud, everything is going to be loud. You're going to do the first day and loud.
In physics, Steve?
So R2, he got 16 kilometers, is that right? Theta,
I think Steve's lying because he told us that.
he got 9 halves, is that right?
Yeah, because the girls, the cheer.
9 halves radian. So that's going to be,
I'll just.
yeah, 36 over 8, yeah,
It's okay.
902. Okay? Right, questions about that? Is everybody good about that? And then, what it is, we're dealing with applications, 35 and 36 to, and I want to be and you're going to have one like 35 and 36 on your test. So I want to make sure you have a look at that. Okay, thank you, ladies and gentlemen.
Yeah, no.
You don't have to say that.